on a night in December of 1975, I'm pretty sure it was then, Dennis White and I were sitting at the computer center, and the first version of a program I called Cyclone had worked. Cyclone cycled nodes. It was technically the way of solving the segment problem, that you would have two segments that were going to join, and you would figure out that because they joined at a node. And nodes were the center of our life. We were thinking that the node was the thing that would link everything together. And when you found a node that just had two segments at it, then you could push the two segments together and everything would work. And that was really the core of what this thing had to do fast. And we proved that Cyclone worked. And from that, we had this moment in which we designed the whole rest of what was going to take us 3-4 more years to put in place. We designed a system. We weren't designing a program anymore. We were designing a system. It was a system of processors. It was a system of processors that were going to handle stuff dynamically and in interesting ways. They were going to solve big problems. And we knew that it had to solve the polygon overlay problem, or it was nothing. That the polygon overlay problem was the core problem. And we did a lot of work developing the ideas behind a polygon overlay processor. We had a first version of it working in 1977, 1978, early 78, that we scrapped. We had tried to do everything in one step, in one pass. And the one-step process involved intersecting all the lines, finding all the intersection points, cutting everything up into pieces, assembling the nodes that would then fall out of that, and then creating the polygons and naming the polygons with the correct names from their source materials from the two different maps that formed the map overlay. Well, it turns out that it wasn't ready to work, that we had to do all the intersections, make it all clean, stabilize it, and then create the polygons in a second pass. Basically, it worked all right if the tolerance was set to 0. Because one of the things that we had done is we instituted a tolerance. We'd said, no coordinates are perfect. All coordinates are fuzzy. And our intersections are going to be imprecise. And we have to account for that. We have to provide a tolerance. This is the first case that we know of a polygon overlay processor that was open about handling a tolerance that allowed the tolerance to become large relative to the size of the polygons. In fact, the test of the system in the long run was to set the tolerance bigger than the database. Okay, what is the tolerance? The tolerance means that these are points that are within a tolerance and they don't matter. Okay? If they're within the tolerance, they're the same. So if your whole database is within the tolerance, what do? The whole map should go. You should get nothing as output. This is sort of tricky, but it's what we did. And Jim Dugnick had lined it all up. We put in a database of the United States, 48 states. We set the tolerance to be, a few 100,000 miles. And lo and behold, all the 48 states came in. They vanished into one node, and then poof, it said, poof, there are no lines left. Nothing for output. So we got a null output file. And we were cheering. Okay? We were cheering that we had a null output file. There were 4 of us who were full-time programmers on the Odyssey program. Dennis White and myself were involved from the first day. Probably the next day, we went and talked it over with Jim Dugnick. And Jim became a part of the project, just because he had a very cool head for talking over problems. And then we found enough support, enough financing to be able to get him funded to work on the project. Scott Morehouse was hired just around this time. We were, we were morning kinds of people. And we would always be ready to throw out a piece of the software. Nothing was sanctified and cast into stone. This annoyed certain members of the team. There was a time that I was having a discussion, a heated discussion, with my esteemed colleagues. And for some reason or another, I had a great big stick in my hand. And I was saying, well, the ideas in this software are going to be worked out by a Darwinian selection. And I was holding this stick. And Dennis said, oh yeah, and he picked up this other stick. He said, we're gonna fight it out. We're gonna fight out the details inside the software by contention. But the contention was actually very good-spirited. It was not a fight of any real sort. It was that we were all committed to a common goal here of making a really world-class piece of software. We wanted to make a difference with the software.